fixed point iteration method to solve any nonlinear equation in one variable. So how do we solve this problem, isn't it? So this is the last method among 5 methods to solve nonlinear equation in one variable. So how do we apply fixed point iteration method to solve any nonlinear equation in one variable? So look at this name of the methodology, fixed point. So what is the meaning of fixed point? That means the considered value of variable will be fixed initially. Alright, so only one point will be considered gauge value initially. So, and look at here, iteration. These words gives you an idea you have to apply or perform same operation more than one times. If I ask you to do only first iteration, that means you have to do only one iteration. If I ask you to do 3-time iteration, that means you have to perform first iteration, then move on second iteration, then you have to do third iteration, and after that you will consider the solution of the nonlinear equation in one variable based on the requirement of the examiner. Alright, so similar type question could be arise in any assessment. So be careful and try to practice a lot when you get time. So this is the algorithm. This is the algorithm. So what is about fixed point iteration method? So at first you have to know about how do we find a real root, that means a root of a function. What is the process? So let me show you. I need to open new page. Just give me a couple of seconds. Okay, I don't need to open new page here exactly. I need to open new page here. So just think about it. We have to solve a nonlinear equation in one variable by using fixed point iteration method. All right. So okay, if I need to open new page, then I will do it later. Just start from here. So look at here. What do you see? Suppose you have a function. All right. So suppose you have a function and you should find the root of the functional equation. So how do we get it? Suppose I give you function f of x. Alright. So you have to make this function as an equation. So this is functional equation, right? This is first step. So move on next step. From this equation, you have to make x equal to z of x format. X equal to z of x format. So from f of x equal to 0, you have to make x equal to z of x format. So how do we make it? I will show you. Don't worry at all. So next step B, you have to check z prime of x naught then you have to do absolute of this value and you have to check is it less than 1 or not. If you get z prime of x naught that is less than 1, and please remember you have to take absolute value of z prime of x naught. If you get this value is less than 1, then only you should move on step number 4. Otherwise, you have to make these x equal to z of x format in different form. That means you have to choose x equal to z of x in different format that comes from f of x equal to 0. So as simple as this x equal to z of x is not unique. This format should be changeable, isn't it? So what is about step 4? You have to use or apply these iterative formula. So if you have z of x, then you can substitute xn instead of x here, and at left hand side you have to mention x of xn plus 1 because this is an iterative formula. You have to consider n equal to 0 for getting x on. So when you get x on value, you have to do this operation. And if you get this absolute value of x on minus x naught less than equal to epsilon, then only you can stop your calculation to predict the solution of a nonlinear equation. So if you see, okay, this is greater than epsilon. Sometimes you can get greater than equal epsilon. So sometimes you can get greater than epsilon or less than equal epsilon, isn't it? So if you get, we get this value, this is exactly greater than epsilon. So what we should do? When you get this value is greater than epsilon, you have to consider n equal to 1. Then you can get x2 value, isn't it? And in the z function that you got from x equal to z of x, here in this z function you have to substitute x1, isn't it? So when you substitute x1 instead of x in z function, you will get this one, isn't it? So you can get some value of x2. Next you have to perform these operation. Look at the value of it. If you get this is less than or equal epsilon, so just stop the calculation. x2 is the required answer as a solution of nonlinear equation in non-variable. Sometimes I can ask you, or this could be a requirement, you have to select or estimate the solution of nonlinear equation in non-variable up to 3 decimal places. That means you have to consider 3 digit next to decimal marker of the value of x2. Alright, suppose you have x2 value 0.329 on 53. So if I ask you to find x2 value up to 3 decimal places. So what will be the answer now? This one, isn't it? So you have to check the convergency when you get convergency arise, then only you should move to do iteration. That means, how do you check convergency? From here, if you get absolute values of z prime of x naught that is less than 1, that means this iterative formula will converge, otherwise not. Look at here, this is an example. So where you see f of x function that is given to you and an iterative formula that is also mentioned here, that can be used to estimate the root of f of x equal to 0. And you have to read each sub-question very carefully. So look at here. So we have a function. So from this function, f of x equal to 2 times cos 2x plus 2 minus x. From this function, you can get these iterative form. How? How, isn't it? Let me show you. So at first you have to write this function, this is equal to 0. So from this function you can write 2 times cos 2x plus 2 minus x equal to 0. So you can rearrange these equation to get x equal to z of x function. So how do we get it? Suppose you can rewrite this equation in this format. Alright, in this format, then just shift this term in left hand side. What do you get? So if you would like to keep only x term in left hand side, what do you get? Isn't it? So you can write x equal to z of x. So that means you have z of x, this is equal to only this portion. Isn't it? So do you understand how do we get z of x now, and how do we get iterative form? Look at this one. So you can write x suffix n plus 1, this is equal to z of xn. Do you remember this form? X suffix n plus 1, this is equal to z of xn. So you already have z of xn, this one. Now you have to insert z of x function exactly here. Just substitute it, then you can get this iterative formula. So if you want, you can make another iterative formula from here. Just give me a couple of seconds. I need to write this functional expression. 2 times cos 2x plus 2 minus x. Isn't it? So you can write this on like this: x equal to 2 plus 2 cos 2x. So you can write this. So you can apply this iterative formula if you get z prime x naught less than 1. What is about this x naught? This x naught comes from exactly here. So state the reason whether the iterative formula will converge to the root near the point. So you have to find near point that has been fixed. So look at here, this x naught is fixed initially. So what is the next step? So when you get the iterative formula will converge, you do iteration based on the requirement of examiner. So if examiner asks you to do one iteration, then you have to consider n equal to 0. That means when you consider n equal to 0, you will get first iteration, and after doing first iteration you will get x1 value, isn't it? So what is about this one, right? Next, if I ask you to do second iteration, you have to consider n equal to 1. And here you have to apply same iterative formula to get x2 value. And look at here, in this z function you have to insert x on instead of x, isn't it? In z function you have to insert x on value instead of x. So from where you get z function, this z function comes from x equal to z of x. That means this portion that should be inserted here. So instead of x, you have to insert x on. If I ask you to do third time iteration, then you have to consider n equal to 2. Then you will get x3 value. So since this is the requirement of examiner here, you have to do say 2 times iteration to get the value as a solution of a nonlinear equation in non-variable. So look at here, all calculation has been done here. So you get x2 equal to 3.502129. You get x2 value, this one. Look at the question. Yeah, all right, you already estimate the root of the nonlinear equation in non-variable, but look at the requirement. So another requirement is here, you have to choose or estimate the solution up to 3 decimal places. That's why you have to keep only 3 digits next to decimal marker. This is the required answer based on the question. So next, if you have to write MATLAB command to estimate the iterations process, how do you execute these iterations 5 times or 10 times or 11 times? So if you write a code in MATLAB software, then you will save your time, isn't it? Look at here, this is the MATLAB code. So you have to define the iterative formula at beginning, then you have to mention initial guess value, then you have to apply for loop, and inside this for loop you have to call this function like this. Then if you run the code, you will get this outcome. So this x value will be stored in workspace. Okay, so here is the exercise problem. So this is the given function, and you have 2 iterative formula. So look at here, you have to find these iterative formula will converge or not, and you get initial guess value x equal to 1. That means you can define x not equal to 1. So now you have to follow the algorithm to find the convergency of these iterative formula, this one and this one respectively. And you have to choose if these iterative formula will converge, then you can apply this iterative formula to estimate or find the root of this nonlinear equation in on variable. Okay, if you get now here this iterative formula doesn't compare, which iterative formula will converge, isn't it? Otherwise you can't apply either this iterative formula or this iterative formula to estimate the root of these nonlinear equation in non-variable. What is the pre-requirement? Iterative formula should be converged. Otherwise, you can't apply your choosable iterative formula to find the root. So look at here, the fixed point iteration method defined as this one, that converges if. What is the correct answer? Look at here, look at this option. Which one is the condition to converge this iterative formula? Than or equal one. So what will be the correct answer?
Neither.
Exactly. So look at options very carefully. Please try to practice this similar type question, because yeah, I will throw MCQ question, so you should practice. So anyone have any question? Anyone have any question?
No, ma'am.
Okay. Now I am going to discuss with you the system of nonlinear equation that have to be solved by using either Newton-Raphson method or fixed point iteration method. That means you can apply Newton-Raphson method, you can apply fixed point iteration method to solve the system of nonlinear equation. Alright, so let me discuss with you how do we apply Newton-Raphson method to solve the system of nonlinear equation. So do you know what is about the system of nonlinear equation? What is about the system of nonlinear equation? Don't worry. Yeah, let me check the time at beginning. Okay, then yeah, we have enough time. So we can discuss. Okay, tell me what is just tell me what is about system of nonlinear equation. Just give me example of a system of nonlinear equation. Don't worry, I'll show you. So consider this is nonlinear equation, right? So you can consider here another variable t. Do you know the value of x, y, t? No. So
No.
you so you can define this is f1 function. How about variables of this equation? X, y, t. Isn't it? So you can define this equation in this format. Next, suppose this is your another equation. So this is also another nonlinear equation, isn't it? So you can define this is f2 functional equation. You can write this on. Suppose you have another nonlinear equation. So what will be the functional equation now? You can write this on in this format, right? So how do we consider t as a variable in third number equation? So suppose you just do this operation here. 0 times t plus xy plus cos x plus y square equal to 0. Isn't it? So you can consider t is a variable for third number functional equation. Because other two equation you see in other two equation t variable exists. That's why you have to consider in third number equation t variable exists. So you have now three functional equation. So from these three functional equation you can keep only these functions together and you can make function matrix from them. f1 of x comma y comma t, f2 of x comma y comma t, and f3 of x comma y comma t. Alright, so this is a column matrix. And how about variable matrix? This is a function matrix, okay? And how about variable matrix? Variable matrix can be defined by capital X, and this is a column matrix also. So here you have to write variables in a column, okay? So this is a variable matrix. So when you have variable matrix, when you have function matrix, you can make Newton-Raphson iterative formula in matrix format. Isn't it? So what is the meaning of J inverse? What is the meaning of J inverse? J defines Jacobian matrix. And always remember, Jacobian matrix should be a square. So how do we get this Jacobian matrix? You have to do this operation. Del f on del x, del f on del y, del f on del t. So this is the first row of Jacobian matrix. How about second row of Jacobian matrix? Del f2 del x, del f2 del y, del f2 del t. How about third row of this Jacobian matrix? Del f3 del x, del f3 del y, del f3 del t. Isn't it? So this is Jacobian matrix. So from where you get f1, f2, f3, come back here. This is f1 function, this is f2 function, this is f3 function. When you have Jacobian, suppose, okay, let me write it down in this format. A suffix 1 on, A suffix 1 2, A suffix on 3. Next, rows element be like this, isn't it?
Yes, ma'am.
So our target is we have to make inverse Jacobian matrix. That's why we have to find adjoint of Jacobian matrix. If you would like to follow cofactor methodology. So what is about in what of element a small a suffix ij. Alright. So from here you get a small a suffix ij. Come back here. This is a small a suffix ij. Isn't it? I defines row number, J defines column number. So if you would like to get capital A suffix 1 on, what you get from here? So this element exactly exists here. So you have to find capital A1 on. How do you get it? Come back in this Jacobian matrix form. So take same positional element. Okay. You have to discard this row and this column where exactly exists selected element. So how about remaining element in this Jacobian matrix? A22, A23. So A22, A23, A32, A33. Isn't it? So if you do this operation, you will get capital A suffix 1 on. So just follow this formula to find capital A suffix on, capital A suffix on to till capital A suffix 33. Then if you do transpose of it, you will get adjoint of Jacobian matrix. Then you have to apply this formula. Okay, you can write here inverse of Jacobian matrix. Then you have to do this operation to get inverse Jacobian matrix. So you already know the determinant operation of a square matrix. Just do the operation here. You have to find determinant of Jacobian, or you have to do this operation. If you get this is not equal to 0, then only you will be predict inverse Jacobian matrix, otherwise not. So when you have inverse Jacobian matrix, you can easily apply this matrix format. Let me show you. All right, so you suppose you have to do second time iteration. So what we have to do now? So initially you get x naught value. This is initial guess value. So for doing next iteration, you have to, okay, when you apply this x naught initial guess value, you will get x on, isn't it? By using this initial guess value, you will get x on value. This is calculated value, isn't it? So when you consider n equal to 0, you will get x1 value after doing first iteration. If someone asks you to do second iteration, here you have to consider n equal to 1 to do second iteration. If you have a system of nonlinear equation, so this suppose this system have more than one variable. Suppose x1, y1. So how about another guess value? Why not? Isn't it? So you will get again here y2 value. So here you have to insert x1 value instead of x, y1 value instead of y. Alright, so you can easily get updated value of estimated root after doing required time iteration. So please go through these advantages and disadvantages points and come back here. Here is the problem. So similar type problem could be arise in any assessment. Suppose I give you this system of nonlinear equation. So how many variables exist in these two equations? 2, isn't it? X, Y. So you can define this is f of x comma y equal to 0. You can define z of x comma y, this is equal to 0. That means you get f of xy, this is equal to x square plus xy minus 7, and z of xy, this is equal to y cube minus 2x plus 4. Isn't it? By using these two functions, you can make Jacobian matrix. Have to calculate Jacobian matrix. So how do we find this Jacobian matrix? We already know Jacobian matrix can be written like this: del f del x. Because we have x variable, we have y variable. So you have to do this operation del f del y. Similarly, you have to do this operation del z del x del z del y. If you do this operation, you will get this. So what do you get from here? 2 times x plus y minus 0. So you can get from here 2 times x plus y. Isn't it?
ম্যাম এতক্ষণ শোনা যায়নি ম্যাম।
So where you are exactly?
ম্যাম জ্যাকোবিয়ান ম্যাট্রিক্সটা যে লিখেছেন।
All right. So you already see Jacobian matrix form, right? Just do
Yes,
these operation del f del
Yes,
x.
ma'am.
Okay, this operation I have done here del f del x. So you get here 2 times x plus y, right? So look at here 2 times x plus y. So if you do, okay, if you do this operation del f del y, what do you get? Del y of f function x square plus xy minus 7. So what do you get? What do you get? Only x, isn't it? because you have to do first time derivative of x square with respect to y. So you get 0 here, then plus, you get x here, then minus 0. So finally you will get x. So what is about del f del y? X. So if you do del z del x, then you will get minus 2. If you do del z del y, then you will get 3y square. So I will show you del x of z. What is about z function? This is this one. So y cube minus 2 times x plus 4. What do you get from here? Only minus 2. That's why this minus 2 is written here. So when you have Jacobian matrix, so you can easily get Jacobian matrix. Okay, you can easily find Jacobian matrix at initial point. Suppose Jacobian of x naught y naught. So what do we get? 2 times x naught plus y naught minus 2, then x naught, then 3 times y naught square, isn't it? This is Jacobian matrix at a specific point. So look at the question. So this is initial point. That means x not equal to 1.5, y not equal to minus 1. So if you substitute x not equal to 1.5 and y not equal to minus 1, you can get Jacobian matrix at x naught y naught point. Then you can easily find determinant of Jacobian matrix, isn't it? So look at the second question. Here you have to derive or calculate Jacobian matrix at this point. So what you should just substitute equals 0. So when you get Jacobian determinant of Jacobian is not equal to 0, then you can get inverse Jacobian matrix. So this is the process to find inverse Jacobian matrix. Okay. So how do you get it? Suppose this is a Jacobian matrix. Let me write it down for you. Then I will show you what is the calculation that you can see here. So how do you get it? How do you get it? I already show the process, isn't it? I already shown to you the process. Do you remember? Do you remember? I already show you here. So you have Jacobian matrix. Here you get 3 by 3 matrix, and in example you will see 2 by 2 matrix. It doesn't matter. You have to follow the process to find adjoint Jacobian matrix. What it is? You have to find cofactors of each element. You have to follow this formula. And when you get cofactors, you have to do transpose of it. Then you will get adjoint of Jacobian matrix. So for getting Jacobian matrix, you should follow the formula. And if you follow the formula and if you get inverse Jacobian matrix, finally you can apply matrix form of Newton-Raphson formula. Now come to this point. If you do this division operation, okay, just minus 1.5 by 9, so you will get minus 0.0666. Similarly, if you do 2 divided by 9, you will get 0.222. Okay, so you have now inverse Jacobian matrix. So you have function matrix. What is about Do you remember? You have function matrix, you have variable matrix, you have inverse Jacobian matrix. So you can insert these information in this iterative matrix form, isn't it? So suppose you have to do 2 times iteration. Okay, you have to do 2 times iteration. So what you should to do, you have to consider at first n equal to 0, and when you consider n equal to 0, you will get x on some value, you will get y on some value. All right, next you have to consider n equal to 1, because this is the requirement. You have to do 2 times iteration. If you see in the question anywhere the times of iteration is mentioned, so if you consider n equal to 1, you will get x2 value, you will get y2 value, and these are the required solution of a system of nonlinear equation. So come to this specific problem. So if you consider n equal to 0, then you will get x suffix 1, this is equal to x naught, this is equal to x naught minus j inverse for n equal to 0, and the function matrix for n equal to 0. Just substitute n equal to 0 everywhere. What do you get? To write x naught, y naught, because you get here suffix 0. Next, minus. What is about inverse Jacobian matrix at n equal to 0? What is about inverse Jacobian matrix at n equal to 0? This one, isn't it? You have to insert this on here. Here n equal to 0. So x naught square plus x naught y naught 0.583, 0.388. So the value of x on is exactly this one, and the value of y on is 0.388. So after doing one iteration, you have to consider n equal to 0, and you will get x on, y on. If I ask you to do second iteration, then you have to consider n equal to, n equal to 1. Then you will get the variable matrix like this. Isn't it? So what you get from here, x2, y2, this is equal to x on, y on, minus, you will get inverse Jacobian matrix at x naught, y, x on, y on. So just substitute here, you have function matrix at x on, y on. That means to get this function, you have to consider x on, y on. To get inverse Jacobian matrix, just substitute x on, y on instead of xy. So you can get a column matrix. So x2 equal to this value and y2 equal to this value. Do you understand the procedure? Anyway, and you can follow this code. You can follow this code to find the root of the system of nonlinear equation in one variable after doing required times iteration. Write command in MATLAB software to execute the iteration 7 times. When you see these number, you have to use a loop to do these operations several times. That is required. So look at here. Okay, let me. Is it erased? Yeah. So look at here. 7 times iteration. So you can start for loop here that start from 1 and end exactly n equal to 7. So you have to mention, okay, what is about variable matrix, then you have to mention function matrix, then you have to write Jacobian matrix, and this is the matrix format x1, this is equal to xn minus this Jacobian, okay, this one, then divided by function. Okay, so here you get inverse of Jacobian matrix. Okay, inverse of Jacobian. So this slash symbol applied to define inverse Jacobian. Okay, that means slash symbol is used to define inverse of Jacobian. Then fn. All right. Next, you should suffix n plus 1, then you will get all updated value in x and y variable that can be stored in new variable rows, so that you can get roots. This one, first column defines x value, second column defines y value. Let me check what is the time right now. Yeah, I'm coming soon. Or you can give command fsolve to find the root of the system of nonlinear equations. So this fsolve command can be used. So you can get this code here. So what is about? Look at this code. At beginning you have to mention the function, isn't it? And this function comes from the provided system of nonlinear equation. All right, then you have to mention what is about gaze value x naught, isn't it? What is x naught? In this variable assessment, here you see multiple choice of question. I already discussed with you what type of question could be arise from each lecture topics based on the discussion topics, right? Suppose Newton-Raphson formula converts. That means x naught equal to 0. So how about variable here? X1 and x2, right? So you have to consider x1 equal to 0, you have to consider y1 equal to 0. Then which of the following is the correct MATLAB command? So look at here, you have to define the function at beginning. suppose I give you another option like this. So Iftikharul, are you here?
Yes, ma'am.
Just tell me where I did wrong in option E, where I did wrong. So this is the, just think about it. I just throw the question to everyone. I will, okay, I just
if
throw
solve
this
পরে ম্যাম
question.
কলম দিয়েছেন এটা
Sorry, yeah, tell me.
if solve লাইনটার মধ্যে কলম দিয়েছেন সেমিকোলন দিয়েছেন
Semicolon. So what is that? Epsilon here.
ম্যাম if solve সেকেন্ড লাইন
Epsilon. I can use only comma, then semicolon. So we can use this one here. So I did wrong twice times here. What I did, the command is wrong. Capital F SOLVE. What is the right command? A small f SOLVE. Right? So I did wrong here. And I did a big mistake here. So this is the question that I throw to everyone. So I will ask the answer of this question in next class. Okay, so find where exactly I did wrong in this E option. Okay, this is the question that I throw to everyone.
ম্যাম লাস্টের ফাংশনটা আগে লিখতে হবে
So do you agree with the answer? How about others' opinion?
Yes, ma'am. সলভটা সবার শেষে লিখতে হবে।
So okay, I get the answer of the questions.
Assalamu alaikum.
Walaikum assalam. Walaikum assalam.
আসসালামু আলাইকুম।
Walaikum assalam. Walaikum assalam.
হ্যালো ম্যাম।
Yes, please.
ম্যাম অ্যাসাইনমেন্টের টাইমটা কি একটু বাড়ানো যাবে?
ইয়েস ম্যাম, একটু বাড়াই দিলে ভালো
ম্যাম
হতো।
Okay, so I can extend the time till tomorrow 5 p.m. But if anyone,
ক্লাস আছে এক্স্যাক্টলি।
I already gave you 1 week. This is not a very a small time, right? Anyway, I will extend the time till tomorrow midnight, not more than that.
ওকে ম্যাম, থ্যাংক ইউ।
Yeah, and remember,
Thank you, ma'am.
who already submitted your homework don't need to submit again. I will throw new link to you. I will give you new link to you. So if you যারা বাকি আছেন অথবা ওই
ম্যাম
লিংকটাতে
আপনার কথা
সাবমিট করতে চান।
শোনা যায়নি।
ম্যাম এতক্ষণ কথা শোনা যায়নি ম্যাম আপনার।
ওকে, সো আমি আজকে আপনাদের একটা লিংক নতুন করে অ্যাসাইন করব হোমওয়ার্ক সাবমিট করার জন্য। যারা প্রিভিয়াস লিংকে হোমওয়ার্ক সাবমিট করেছেন তাদের নতুন করে সাবমিট করার প্রয়োজন নেই, ঠিক আছে?
ওকে ম্যাম।
আর যারা আজকের মধ্যে সাবমিট করতে চান প্রিভিয়াস লিংকটাতে সাবমিট করে দিবেন, ঠিক আছে? আর যারা দেরিতে করবেন আমি তো দেখতেই পাবো। অলরাইট, সো থ্যাংক ইউ।
Okay, ma'am. Thank you.
Yep. Alaikum assalam. All the best. Please leave the class as soon as possible.
ম্যাম আসসালামু আলাইকুম।
Alaikum assalam.